In this video, we'll do an introduction to statistics. Now, statistics is the science of collecting, organizing, analyzing, and interpreting data to help us make decisions. We often need variables to do statistics. We need to know what is it we want to know. What are the characteristics we want to study? If there are no variables, there's no reason to do statistics. Once we know our variables, we know what data we need to collect. And that's going to be any information that's going to help us understand those variables. It could be observations, surveys, measurements, counts, even responses. But we need data based on our variables to perform the statistics. As we do statistics, we have to recognize what is the population and what is the sample we may need to do the statistics. A population is the collection of all outcomes, responses, people or groups or counts that we want to know and understand. The sample is a subgroup, a subset of that population. Now, why might we want to do a sample? There's three key reasons. First, it takes a lot less time to perform statistics on a sample. It costs a lot less money to collect the data and perform the statistics on a sample. And often, it is excessively challenging to actually survey or study an entire population, depending on the size of the population. So many times, it's just not practical. Think about if you were a biologist wanting to understand fish in a lake. There could be thousands of fish in the lake. Trying to get every single fish from the lake could be virtually impossible. But by doing sampling, that could help you better understand what was occurring in the lake around whatever variable you were studying with the fish. Let's look at another example. Say we have a random sample of 700 Virginians who are asked if they plan to vote in the upcoming election. 548 said yes. So the variable that's being explored here is voting habits and voting plans. Now the population would be all the people that live in Virginia. However, that would be virtually impossible to try to actually sample and survey. So instead, a sample is performed of 700 Virginians. So that by using those 700 Virginians, we can get a better idea of what the population may be considering for the upcoming election. There is error in our samples, which is often why you see a range, like a plus or minus at the back of a percent that's given for such a survey. And that's to tell us that there's a range of what we think the population will really do, but we're pretty confident it's pretty close to this value. Now we also have parameters in statistics. Parameters help us understand characteristics about the population, whereas statistics are characteristics about the sample. So often that is why we find statistics and not parameters, because finding the information about an entire population is exceedingly challenging. So let's look at some examples to determine, is it a parameter or a statistic? Say we have a survey of 800 Radford students. 65% said their favorite class is math. Now, we first have to understand, what is the population? In this case, our population are the students at Radford. Then we have to ask ourselves, was every student surveyed? Well, here it says 800 students, but there are thousands of students at Radford. This means that what was done was a statistic. It was a smaller subgroup. It was a sample of all the students. So that represents the statistic. Now say we had 14 of 21 department faculty members earned a PhD. Here, the population, we have to ask, what is that? Well, it's the department faculty members. Did we actually look at all the faculty members? Well, it's saying 14 of the 21. So yes, it looked at all 21 and said this is a true statement about 14 of them. That's a measurement, a value, a characteristic about the population of department faculty members. So there it is, a parameter. And this is why it's important to understand, what is the population? Because we can have very large populations like the United States or Virginia, or we can have very small populations like a single class, or in this case, a department. Now we have two primary types of statistics that we will discuss. One is descriptive statistics and the other is inferential statistics. In descriptive statistics, we're organizing, summarizing, and displaying the data that we gather from our studies or surveys. Inferential statistics takes that data and then draws conclusions about the population. So we have to understand there's a difference here. Descriptive describes exactly what was found from the study or survey. Inferential then applies that to draw conclusions. So say we have a large sample of 35-year-old men that was studied for 25 years. So this is a longitudinal study done over many years. For unmarried men, approximately 73% were alive at age 60. For married men, 93% were alive at age 60. So the variable that's being looked at here is what's the mortality of men by age 60? And trying to understand, does being married or unmarried influence that at all? That's what we're trying to understand. So the descriptive statistics is the exact information that was found from the study. 73% of unmarried men were alive at age 60, whereas 93% of married men were alive at age 60. So then the question is, what can be inferred from this statement? The inferential statistic is that being married may be associated with a longer life for men. That can't be a guarantee, but it's what we infer based on this longitudinal study. Now, when we're sampling our data, we're trying to create a subgroup that actually represents the population. If our sample is biased, we cannot make accurate inferences about our population. Just like in that previous example, if it wasn't a random sample, then we wouldn't be able to accurately say whether what we're doing does represent the larger population of men that are married or unmarried. Often this occurs when we go for convenience samples, or sometimes groups may try to deliberately distort the accuracy of data by only sampling their individual members. This happens way too much, especially with online surveys where they send it only to the members of a group, and then you see these overwhelming percentages that match exactly what that group wants to believe. Whereas unbiased sampling has to include some form of randomization. Often we will talk about simple randomization, and that's primarily what we will do in this course, where every possible item in a population has an equally likely chance of being selected for the sample. If there's 1 million people, every person in that group has an equally likely chance of being randomly selected to participate in that survey. Now, there are various forms of randomization which can be done for different reasons, and they are considered appropriate randomization for unbiased sampling. These are considered stratified, cluster, and systematic random sampling, and there can be others that you may learn about in other courses. We're going to stick to simple random sampling. So let's just look at 2 examples and determine, is it a random or biased sampling method? So say you ask the first 10 people that enter the classroom if they studied for the test. You ask yourself, is that a biased or random sampling? Now, one of the things you can say to yourself is, did every single person in the class have an equally likely chance of being selected to be asked this question? Now, some students may be coming from the other side of campus and always come right before class starts, or maybe a minute or 2 after class starts. If that's the case, did they have the same chance as maybe someone that doesn't have a class before and always comes early? Probably not. Also, maybe the studying habits of people that come early is different than people that come late. It could be very different, and we just don't know. For that reason, we consider this a biased sample. You're doing a convenience. Who's the first 10? I don't have to think about what does it mean if you come the next 10 or the last 10. Instead, I'm just going to take the first 10 because that's the easiest thing for me to do. Often, if it's the easiest thing, it's a convenient sample, and that's not a good way of sampling. Now, say instead, the teacher decides to put everybody's name in a hat and then says, I'm going to pull 10 names out of this hat. I'm not going to look at it, and I'm going to ask them if they studied for the test. Does everyone have a chance of being selected? Yeah, every student's name is in the hat. The teacher's not looking directly at the names, or just randomly trying to pull out 10 names. So that is a simple random sample. However many people there are, each of them have a strip in the hat, and they can be selected. They have an equally likely chance. That's why that's simple random. We also have to understand that there are categorical and numerical variables. Numerical variables are data that are in the form of numbers and can be measured and counted. So that's the key right there. They have to be able to be measured and counted. If they can't be measured or counted, they're likely a form of a categorical variable. And this is data that is non-numerical. Now that word non-numerical can throw people off, but it's important to recognize that categorical variables are ones that are made up of words or non-countable strings of numbers. So you can think to yourself, what are non-countable strings of numbers? Zip codes, phone numbers are probably the two most likely ones you ever can think of. So here, if we look at numerical and categorical variables, zip codes, I just said that is considered categorical data because it is a string of numbers, but we don't measure or count zip codes, just like we don't measure or count phone numbers. They are a string of numbers that tell us a specific information about maybe where you live. And even more specifically, that'd be like the first 3 digits, the area code tells us a very specific place about where you lived or where you got your cell phone. Whereas, say we wanted to know the distance between Radford and Christiansburg, that would be numerical because you have to measure that distance. You actually have to pull out, are we doing it in meters, kilometers, miles, feet, yards? There's a way we can be measured and count that distance from Radford to Christiansburg. So when we think about an introduction to statistics, we have several keywords to understand and how they have some competing or connecting terms with them. We have populations, and once we know our entire population, we can take a sample of that population to help us do our studies. Parameters help us understand an entire population, whereas statistics is information about the subset, the sample. We use the descriptive statistics to help us understand exactly what came from the sample, and we use that to make inferences about the population. As we sample, we want to avoid our convenience and bias sampling and go for random sampling whenever possible. And then it's important to understand that we do use sometimes categorical data to look at our grouping, but also that we can do more diverse and complex types of statistics once we have numerical data.